This is my sixth video lesson for the covalent bond unit. In this lesson, we'll be learning how to draw the 3D structure of a molecule. So let's go to page 20 in the class packet. Motivation, which might be the actual 3D structure of water. So take a moment to think about it. Learning target. At the end of the lesson, I'll be able to draw and identify the shape and geometry of a molecule using the VSEPR theory. There will be a homework Junipod based off this lesson. There will also be a quiz Junipod based off PowerPoints 4, 5, and 6. VSEPR stands for Valence Shell Electron Pair Repulsion. This theory is used to predict the shape of a molecule. I first want you to watch a TED video about this theory. The video link is in the descriptions. Once you watch the video, resume this video. I assume everybody has watched the video, so I'm going to quickly summarize what was the video about. Molecules in reality have 3D shapes. They're not just flat. The shape of the molecule is determined by the attractive and repulsive forces in the molecule. A molecule will minimize the repulsive forces and maximize the attractive forces. The bending you see in the structure of the molecule is caused by the electron repulsion between the electron dense areas. So what are electron dense areas? Electron dense areas are the electron pairs and bonds in the molecule. Here is a water molecule. I'm going to circle the electron dense areas. There is a total of 4 electron dense areas in water. So the molecule is going to form a shape to minimize the electron repulsion present in the molecule. Water has 2 lone pairs, and each of the lone pairs occupies space in the molecule. They will cause repulsions with the electrons in the bond, causing the molecule to have a bent shape. Here's a table showing the possible geometry of a molecule given the electron dense areas and the number of lone pairs. Keep in mind, VSPR is not on the regions. On the regions, you just need to know the shape of water, which is bent. This topic is on the SED2 chemistry, and you have to memorize the shape as well as the angles of these shapes. There is a more detailed table on page 21 in my packet. For the remainder of this video lesson, I'll show you how to use this table. Let's start with water. Your first step is to draw the Lewis dot diagram of the substance. Focus only on the central atom. In the case of water, it is the oxygen. Count the number of electron dense areas around the central atom. So we have 1, 2, 3, 4. So a total of 4 electron dense areas. If your molecule have a double or triple bond, it counts as only as 1 electron dense area. If your molecule have only 2 atoms, it is always linear. Of course, these last 2 points do not apply to water. If we look at the table, we have 4 electron dense areas. How many lone pairs is present in water? There are 2 lone pairs. If you match the horizontal and the vertical columns on the table, you can see that the shape of water is bent. So this is the 3D shape of water in reality. This is the only shape you need to know for the regions. So on the regions, just remember water has a shape of a Mickey Mouse head. Learning check number 1. The shape of CO2 carbon dioxide molecule is what? Pause the video and resume once you complete it. So the answer is choice 3, linear. The first step is to draw the Lewis dot diagram of CO2. Then you focus only on the central atom, which is carbon. Count the number of electron dense areas around this carbon. So this carbon has 2 electron dense areas. Keep in mind, a double bond counts as 1 dense area. Since there are 2 electron dense areas, you look at the first row, and there is no lone pairs on this carbon, so the shape of CO2 is linear. Let's look at NH3 now. So your first step is to draw the Lewis dot diagram of NH3. Next, you count the electron dense areas around nitrogen. NH3 has 4 electron dense areas, 3 bonds, and 1 lone pair. Next, you match it on the table. There are 4 electron dense areas and 1 lone pair. So the shape of NH3 is trigonal pyramidal. In some textbooks, they sometimes use dash or wedge lines to indicate the 3D nature in the Lewis dot diagram. For example, this hydrant is pointing back in the plane, while this hydrant is pointing towards you. Learning check number 2. The shape of an NF3 molecule is what? Pause the video and resume once you complete it. So NF3 has the same structure as NH3, so it will have a trigonal pyramidal shape. Now I want you to complete the rest of the practice on your own. Draw the Lewis dot diagram with the VSEPR theory and note the geometry. Pause the video and resume once you complete it. Okay, so here's the answers. So this concludes the video lesson for today. Remember to do the Junior Part homework and quiz.